Okay, welcome to Section 20, Interest, Video 2. We are going to pick up on page 179 with number 4. We are going to consider a $1,500 deposit earning an APR of 3.5% compounded annually. So that is what we've been working on there at the end of Video 1. So letter A, what will the balance be at the end of year 10? Okay, so let's remember our formula. Basic formula. Balance is principal, 1 plus the rate, raised to the time. So when I fill in my numbers, my principal is $1,500. My rate is 0.035, right? Percent to decimal. Got to move it 2 places. And my time is 10 years. So when I plug that into my calculator, doing order of operations, parentheses, exponents, then multiply, I end up with a value of $2,115.90. So after 10 years, I will have, an additional little over $600 just by having this money earning 3.5% compounded annually. I now want you to hit pause. Using that same concept, I want you to do B and C. And, sorry, I didn't talk about this earlier. We're talking about money. So you should always be rounding to 2 decimal places because money is 2 decimal places. So go ahead and hit pause, do B and C, and then come back and check out the explanations. Okay, in part B, we have the same principal of $1,500, same interest rate of 3.5%, but now we're talking about 20 years. So in 20 years, we will have $2,984.68. So in an additional 10 years, we're earning over $800 just in additional interest. So isn't that crazy? And then in letter C, 30 years. So if we talk about the balance, same principal, same rate, but now we're talking about for 30 years, you will have $4,210.19. So not quite triple your money, but almost after 30 years. So if you think about it, if you just throw in some money into a bank and let it sit there and collect interest over the course of 10, 20, or 30 years, you will gain a decent amount of money in interest, right? You've got to have a good chunk of money in there, and let's be serious, you've got to earn a good percent. 3.5% right now for a savings of any kind would be really fantastic. It's just not happening, so that's a little sad. But, it is what it is. Okay, continuing on page 179, number 5. I would like you to hit pause and work through number 5 on your own and then come back and check out the explanation. Okay, now we have a $2,000 deposit, an APR of 2.25%. Let's just start with a remember of 2.25% would be 0.0225 as a decimal. You've got to move that decimal point 2 places in order to work. So now when we look at part A, how much will be in the account after 5 years? We're looking for a balance. Balance is principal, 1 plus my rate of 0.0225 raised to the 5th power. Again, order of operations, parentheses, exponents, and then multiply. I come up with an answer of $2,235.36, and that is rounded to the nearest penny. So then, now that I know my ending balance after 5 years, how would I figure out my interest? Well, hopefully you thought about, the money I started with, the money I ended with. The difference between those two things is how much interest I earned. So if I ended with $2,235.36 and I started with $2,000, the difference between that is $235.36. So in 5 years, doing nothing but letting your money sit, you have earned $235.36, which I'm not going to tell you, I'm not mad about that. Right? That's pretty easy money for not doing anything. Letter C, 10 years. So let's talk about same concept. Balance is the principal of 2,000 times 1 plus 0.0225 raised to the 10th power. And when I do the math, I come up with an answer of $2,498.41. Again, letter D, how do I know how much interest I accumulated? Well, what did I end up with? I ended up at $2,498.41. Subtract my beginning of 2,000, and I end up with an interest amount of $498 So now after 10 years, we are up to almost $500 in just interest, which is pretty nice. Okay, so that's compounding annually. How different would it be here in letter E if we were doing simple interest? So let's come back to the concept. Remember, simple interest is interest equals principal times rate times time. So our principal was $2,000, our rate 0.0225, and our time was 10 years. So if we do simple interest, we would have earned $450. So when you compare simple interest to compound interest, it's almost an additional $50 if you use compound interest, and compounding annually at that. And $50, heck, that buys me a nice pair of shoes. I'd be happy with that. So hopefully this idea of compounding interest annually is working out pretty well for you. So let's flip the page to 180. And I apologize, I took a tiny break in between this, and I'm not sure what I said at the end of my pause. But we're here on page 180, and we have a table. So we have initial investment, so you have your, we have a simple interest and a compound interest column, and they tell you up here in the problem, $30,000 is your principal, APR is 3%. I would like you to fill in, these 4 missing boxes. So hit pause, do them. They tell you the years, are here on the side, and come back, check it out, and then let's talk about what that means and what it looks like. All right, check your numbers, see if that works. Notice how the simple interest goes up nicely. Forget the first one, but if you look down here, 10, 20, 30, 40, between each of those groups, it jumps $9,000. Right? It's consistent because it's linear. Simple interest, you have the same amount every year. Well, when you look at compound interest, it grows slowly at first. So it's not all that different. $81.81 difference from the simple interest in year 3. But then when we get to year 10, we're over $1,000 difference. In year 20, we're up to $6,000 difference. Year 30, over $15,000 difference. And after 40 years, it is more than $31,000 difference. So compound interest over an extended period of time is significantly better in terms of accumulating money in your account. At the bottom of page 180, you see this graph. So you can see simple interest is that gray straight line, right? It's linear, grows the same amount every time. But, and I'm going to use orange, compound interest, you see, has a curve to it. And the further we go to the right in terms of years, the higher that line is going to go, right? It's exponential growth. It continues to get bigger and bigger and bigger. And so far, we have only talked about compounding annually. So that means we are going to compound the money in our account once per year. Well, what if we compound it more than once per year? At the top of page 181, you will see a gray box that I've taken a picture of here, and it allows us to compound our interest more often. And this one actually has a lot of words. You might also see this formula in terms of symbols. So balance equals principal. We know what the principal is, right? That's what we start with. 1 plus our rate is on the top, right? Our APR changed to a decimal. And then I say it's divided by n, where n is the number of times you compound each year. And we'll get to more on n in a minute. And then our exponent is t, which is our number of years, times n. Same n. Okay, and I want to focus on n for a minute. So, we'll make this page all about n. If we want to compound monthly, what would n be if we were talking about monthly? Well, how many months are in a year? 12? Did you say 12? Why, yes, you did. In that case, if we had monthly, n would be 12, because you are compounding 12 times in a year if you're doing it monthly. If you are compounding quarterly, well, what does quarter mean? Well, there's 4 quarters in a dollar, right? There's 4 quadrants, which is kind of like quarterly, in a coordinate plane. Right? Quarterly means 4, so you would be compounding 4 times a year. What if we did weekly? Well, how many weeks are in a year? 52. What if we did daily? Well, how many days are in a year? N equals 365. one thing I want to note with this, there are times, so you want to read directions. We know there are 365 days in a year. There will be times where they will say, use 364 days in a year. And I don't know how often that is said or how often it's used, but I have seen that in my life. So when it comes to daily, just make sure you're paying attention and you read the whole problem. Don't stop reading as soon as you see daily. Read the whole problem. Did you get that? Good. Okay, let's go on to page 181 where it gets to some of the problems. Alright, so this is number 1. Sorry, I missed that part. $2,000 is invested at 6% for 8 years compounded quarterly. So let's go ahead and first let's say quarterly. That means n equals 4. And let's go ahead and plug in our information into our formula. So remember, formula, B equals P 1 plus R over n raised to the t times n power. So our balance, the principal is 2,000. In parentheses, 1 plus the rate is 6%, so 0.06. N, how many times are we compounding? 4. 4 times a year raised to the 8 times 4 power. Now, again, some calculators will whiz right through this. Some will cry foul. So you will want to make sure that you are using order of operations. So if I go inside my parentheses first, right, I would divide, then add 1. And that would give me 2,000 times 1.015, no rounding there, raised to, and if you think about it, what is 8 times 4? 32. So now we have a problem that looks a little bit nicer. 2,000 times 1.015 raised to the 32nd power. And remember, we will want to do this exponent piece first. So take 1.015 raised to the 32nd power, multiplied by 2,000, and our ending balance is $3,220.65. So after 8 years, compounded quarterly, we have an extra $1,200. Okay, let's see what you can do with numbers 2 and 3. So just do 2 and 3 and then stop. All right, number 2, you're investing now. This time, the question says monthly, so we know that n is 12. So let's plug them in. Balance is $2,000. 1 plus 0.06 divided by 12 raised to the 12 times 8 power. So again, you could work inside your parentheses. No matter how you look at it, when you work it out, you should end up with $3,228.29. So if you think about it, we went from quarterly, where it was $3,220, so that was 4 times a year. 12 times a year, we have about $8 more. And then in number 3, we get to daily. And in this case, there's no other specification, so we say daily is 365. So balance is principal, 1 plus 0.06. Daily is 365 raised to the 365 times 8. Now this is a problem where you definitely will want to multiply your exponents together before you plug them in your calculator, because that could be really, really tricky. But you end up with $3,232.02. So almost $12 more than if you did it quarterly. So daily earns more than quarterly. And this kind of leads us to question number 4, which is what pattern do you see when you're looking at these? Well, quarterly, 4 times a year, 3220. 12 times a year, 3228. 365 times a year, 3232. So the more often you compound the interest, right, you adding money to your account, the more you are going to earn. So you want to be compounded as often as possible in order to maximize your investment. Okay, I would like you right now to go into 5 and 6, see what you can do with 5 and 6, and then come back and watch the... Okay, number 5, you're talking about your grandmother who bought you a $10,000 savings bond. Couple things that I want to talk about first. We've got our principal, $10,000. We've got our time, which is 5 years. Now, a 0.10%. Remember, percent to a decimal is 2 places to the left. So this is 0.001 as a decimal. So I want to make sure we got that right. And we are doing this semi-annually, or twice a year. So that means n equals 2, because we're doing this twice a year. So now that we have that information, let's go ahead and plug it into our formula. So our $10,000, 1 plus our rate of 0.001 over 2, right? Rate divided by n, raised to the n times t power. So 2 is n, t is 5. Again, use your order of operations inside your parentheses, raise it to the exponent of 10, because 2 times 5 is 10. And your ending balance for this would be $10,050.11. So if you cashed this out after 5 years, you would have earned $50 in interest, which is probably pretty accurate, because a 0.1% interest rate is pretty much what we're dealing with in this day and age. So $50 for not doing anything for 5 years still isn't too bad. Let's go to number 6. You've got a CD, requires a minimum deposit. Again, so here's my principal, there's my years, APR. 2.5% becomes 0.025 as a decimal, and we're compounding monthly, so n is 12. When I punch them into my formula, a principal of 10,000 times 1 plus 0.025. There's my rate over my n, and then I have n times t. T is 5 years. So you'll notice, compared to the last one, this one has a much higher interest rate, and we're compounding more often. So we definitely should have a higher balance, and we do. Our balance turns out to be $11,330.01, I believe, if I can write. Let me pause this and check my math, because my handwriting, I don't know if it's a 0 or a 6. Hold on. I'm good. That's a 0. I couldn't read my own writing. I apologize for that. So we're going to end video 2 on that one. I've got one more video I want to do for this section, so come back and check out the doubling formula here in the next video. Thanks.